What if I told you that heart disease, cancer, diabetes, and Alzheimer's aren't actually separate diseases at all, but different downstream expressions of the exact same underlying process happening inside your body right now? That's not a wild theory. It's something an increasing number of researchers and physicians in the field of functional medicine have come to believe. And if it's true, it means the way most of us think about preventing disease is fundamentally backwards. Today, I want to walk you through this idea, what's actually driving the aging process at a biological level, and what the current science suggests you can genuinely do about it. Stay with me, because this is one of those topics that can shift how you think about your own health for the rest of your life. Welcome back to VitaRoot Health, the channel dedicated to helping you understand the real science behind chronic disease and aging, so you can make informed choices instead of relying on outdated assumptions. Every video here is built on genuine research, explained in a way that's actually useful in your daily life. If getting ahead of chronic disease rather than simply managing it after the fact matters to you, make sure you're subscribed before we dive in, because this is exactly that kind of conversation. Let's start with a distinction that changes everything, the difference between your lifespan and your health span. Your lifespan is simply how many years you're alive. Your health span is how many of those years you actually spend feeling vibrant, energetic, and functional. For most people, these two numbers don't match. Health span typically starts declining 10, 20, even 30 years before lifespan actually ends, which means a long stretch of many people's final years are spent managing chronic illness rather than genuinely living. The encouraging news is that a growing body of research suggests this gap isn't inevitable. It's largely driven by factors we actually have meaningful control over. So, what determines your health span if it isn't purely genetics? Research increasingly points to something researchers call the exposome, essentially everything your genes are exposed to over the course of your life. Your diet, your activity level, your sleep quality, your stress levels, your relationships, even your environment. Genetics does play a role, but multiple large-scale studies, including well-known research on twins with identical genetics, have found that for many major diseases, genetics accounts for a surprisingly small percentage of actual outcomes. One frequently cited twin study looking at cancer specifically found that only around 10% of cases were attributable to genetics alone. That leaves an enormous amount of room for lifestyle and environment to shape whether disease actually develops. Now let's get into the core idea that ties all of this together, what some functional medicine practitioners describe as a unified theory of aging. The idea is this. Conditions like heart disease, cancer, diabetes, and dementia, while they look completely different on the surface, often share the same underlying drivers: chronic inflammation, insulin resistance, oxidative stress, and mitochondrial dysfunction. Depending on your individual genetics and circumstances, this same underlying imbalance might express itself as heart disease in one person, cancer in another, and cognitive decline in someone else entirely. This reframes disease not as isolated, unrelated conditions we treat separately, but as different symptoms of the same root biological problem. Let's talk about inflammation specifically, because it sits at the center of this entire framework. Chronic inflammation isn't the kind you can see, like a swollen ankle after an injury. It's a slow, silent, systemic process that quietly damages tissue throughout your entire body over years and even decades. One driver of this is something called cellular senescence, where individual cells essentially become old, damaged, and dysfunctional, sometimes referred to informally as zombie cells. Your immune system tries to clear these out, but the process of doing so generates ongoing inflammatory activity nearby, gradually affecting healthy tissue in the process. Multiply that across the trillions of cells in your body over the years, and you get a slow accumulation of systemic inflammation that researchers increasingly link to nearly every major chronic disease we associate with aging. Now here's where insulin resistance enters the picture, and it's genuinely one of the most important concepts in this entire conversation. Insulin resistance happens when your cells stop responding properly to insulin, the hormone responsible for moving sugar out of your bloodstream and into your cells for energy. When this process breaks down, your body compensates by producing more and more insulin, and chronically elevated insulin levels are strongly associated with increased belly fat, more inflammation, and disrupted mitochondrial function, the small structures inside your cells responsible for producing energy. This is significant because research has increasingly connected insulin resistance not just to type 2 diabetes, but to heart disease, several common cancers, and even Alzheimer's disease, which some researchers have started referring to informally as type 3 diabetes because of how strongly it's linked to the same underlying insulin dysregulation. It's worth being clear here. This isn't a fringe or unproven idea. Large-scale data has shown that a substantial percentage of people admitted to hospitals with heart attacks have completely normal LDL cholesterol levels, the number most conventional medicine focuses heavily on. What these patients frequently do have in common is low HDL cholesterol, elevated triglycerides, and evidence of insulin resistance, a pattern that's arguably more predictive of cardiovascular risk than LDL cholesterol alone. This doesn't mean cholesterol is irrelevant, but it does suggest that the full picture of cardiovascular risk is more nuanced than a single number on a standard lab report. Let's talk about muscle, because this is genuinely one of the most overlooked factors in the entire aging conversation. The medical term is sarcopenia, the age-related loss of muscle mass, and research suggests it may be one of the biggest hidden drivers of the broader metabolic decline associated with aging. Here's why it matters so much. As muscle mass declines, insulin resistance tends to worsen. Since muscle tissue is one of the primary places your body stores and burns blood sugar, less muscle generally means less capacity to regulate blood sugar effectively, which in turn drives up inflammation and accelerates the same downstream processes we've been discussing. This creates a situation where someone could weigh the exact same amount at 65 as they did at 25, but have a completely different and considerably less healthy body composition underneath that number on the scale. The genuinely good news here is that muscle loss isn't a fixed, unavoidable feature of aging. Research consistently shows that resistance training remains effective at building and preserving muscle mass well into older age, including in people in their 80s and 90s. Alongside consistent strength training, adequate protein intake becomes increasingly important as we age, since research suggests older adults often need more dietary protein than younger adults to effectively stimulate muscle protein synthesis, the biological process your body uses to actually build and repair muscle tissue. Now, let's bring the brain into this picture, because cognitive decline follows remarkably similar patterns to what we've already discussed. For a long time, conventional medical thinking held that we're simply born with a fixed number of brain cells, and that's that. Modern neuroscience has overturned this. Research has confirmed that the brain retains the ability to generate new neurons and new neural connections well into later life, a process called neurogenesis, supported significantly by a molecule called brain-derived neurotrophic factor, often described informally as fertilizer for your brain. Exercise, quality sleep, and an anti-inflammatory diet all appear to support the production of this molecule, while chronic stress, poor sleep, and a diet high in processed food and sugar appear to work against it. Sleep in particular deserves real attention here, because during deep sleep, your brain activates what's called the glymphatic system, essentially a nightly cleanup process that clears out metabolic waste products that accumulate during your waking hours. Without adequate quality sleep, this cleanup process is disrupted, and some researchers believe this contributes meaningfully to long-term cognitive decline over time. So, what does all of this actually mean for how you approach your own health? The overarching theme running through all of this research is that chronic disease prevention isn't really about targeting one specific condition at a time with one specific intervention. It's about addressing the shared underlying drivers: inflammation, insulin resistance, oxidative stress, and loss of muscle and mitochondrial function that appear to influence nearly all of these conditions simultaneously. In practical terms, that generally translates into a handful of consistent, evidence-supported strategies: prioritizing a diet built around whole, minimally processed foods, plenty of vegetables, adequate protein, and healthy fats, while minimizing added sugar and refined starches, appears to be one of the most powerful tools available for addressing insulin resistance and inflammation at the same time. Regular resistance training, not just cardiovascular exercise, appears essential for preserving muscle mass and metabolic health as we age. Prioritizing consistent quality sleep supports both brain health and the body's broader inflammatory regulation. And managing chronic stress, since elevated cortisol has been linked to worsening insulin resistance, increased inflammation, and even measurable shrinkage in brain regions associated with memory, plays a legitimate, evidence-backed role in this entire picture as well. I also want to mention something that doesn't always get enough attention in these conversations: the role of genuine social connection. Multiple long-term studies on populations known for exceptional longevity have found that strong social ties and a sense of community and purpose are consistently associated with longer, healthier lives, in some research appearing to be an even stronger predictor of longevity than diet or exercise alone. This is a good reminder that health isn't purely a biochemical equation. The quality of your relationships and your sense of purpose appear to genuinely matter at a biological level. Before we wrap up, I want to be clear about something important. This video is meant to help you understand the current scientific thinking around aging and chronic disease prevention, but it isn't personalized medical advice. If you're concerned about your own risk for any of the conditions we've discussed today, particularly if you have a family history or existing risk factors, the right next step is a detailed conversation with your doctor about appropriate testing and a plan tailored specifically to your own situation. Here's the empowering takeaway I want you to leave with today. For a long time, chronic disease and cognitive decline were treated as separate, largely unavoidable consequences of getting older. But the emerging science increasingly suggests these conditions share common, addressable roots, and that means you have far more influence over your own long-term health than you might have been led to believe. That brings us to the end of today's deep dive. If this helped you see the connections between these conditions in a new way, please hit that like button. It genuinely helps this information reach more people who could benefit from understanding this. Drop a comment below and let me know which part of this resonated with you most, whether it was the muscle and insulin connection, the brain health piece, or something else entirely. And if you haven't already, make sure you're subscribed to VitaRoot Health, because we'll keep breaking down the real science behind chronic disease and aging so you can take control of your own health with genuine confidence. Thank you so much for watching. Take care of your body and your mind, and I'll see you